Now we can do probability with any of the counting techniques. So I've got an example of that. So a jar contains 5 red jelly beans, 3 yellow jelly beans, and 4 white jelly beans. 2 jelly beans are selected without replacement. So if we're selecting 2 and you're looking at them, then that would normally be a combination, but it depends on what the question's asking. So I've got a mixture here to show you the difference. So the first says, what is the probability that they are both the same color? So we're selecting 2, both the same color. So how many jelly beans are in here altogether? 5, 8, 12. So there's 12 jelly beans. 5 are red, 3 are yellow, and 4 are white. And we're selecting 2. Both the same color. So you're looking in your hand, you can move them around, you're just pulling out 2. You don't have to do them in order, you're just pulling out 2. So we want 2 red or 2 yellow or 2 white. Or is add, remember? And we're only selecting 2. 2 are red, so out of the 5 red we want 2. Or 3 yellow, we want 2. Or 4 white, we want 2. Okay, so let's see what this works out to be. Now, this is asking for probability. So this is how many ways we can get 2 of the same color. But for probability, so that's 19, probability we want to divide that by the total. So the total is out of 12 jelly beans, we want 2 in any order. 66. So the probability that we get 2 the same color is 19 divided by 66, or 0.2879, or 28.8%, about that. Okay. Now, you could do this another way. If you said 2 red, so the probability of pulling out 1 red, so picture yourself reaching into this jar, there's 12 jelly beans in there. What is the probability that you get a red? There's 5 red out of 12, and then if you reach back in, so this is like taking 2 at the same time, and then just looking in your hand. This would be taking 1 and then another. So now if you've taken a red, to get another red, there'll only be 4 red left, and there'll only be 11 jelly beans left. Or add 2 yellow, do the same thing. There's 3 yellow in there at the start, and then if you take a yellow out, the next one being yellow would be 2 out of 11. Or 2 white, there's 4 white out of 12, and now there's only 11 jelly beans left, so, and 3. Now if we do this calculation, actually I'll type it all out, so 5 divided by 12 times 4 divided by 11 plus 3 divided by 12, oh, I already messed that up. Okay, and you notice we get the same thing. Now that works because I'm saying I'm making sure that I count them down. So you could do it either way. My personal way I would probably do it is this way, a combination, because I would think of them as being pulled out at the same time, because the order Didn't matter, you're just saying both the same color, but either gives you the same answer, depends what you think of first. So that's part A. Part B, okay, let's just remind ourselves what's in the jar. Let's write it down here. 12, 5 red, 3 yellow, 4 white. Okay, what is the probability that one is red and one is yellow? Okay, so let's do this as a combination. So we want 1 red and 1 yellow. So how many red are there? 5, and we want 1. And out of the 3 yellow, we want 1. Okay, so that's how many ways to get those, and we need to divide by the total. Now the total is 12 C2. We're choosing 2 out of 12. .73%. Okay, so that would be to get 1 red and 1 yellow. Now what about this? Is this a different question? Let's see. What is the probability that the first is red and the second is yellow? So the first is red, and now they're putting them in order. So you need to look at the jelly bean in your hand and determine whether it's red, and then the second one has to be yellow. So it's not a combination. You're not just looking in your hand to see if your two jelly beans, one's red and one's yellow. This time we're looking first, did we get a red, and second, did we get a yellow? So how many ways can we do that? Well, there are 5 red. So to get a red first would be 5 out of 12. And that's to get a red. And then to get a yellow, there's 3 yellow in there, but there's now only out of 11. Okay. So they're not the same thing. So what's different about them? This is saying one is red and one is yellow. So the first could be red and the second yellow, or the second yellow and the first red. And you see that it's double this. So that's both ways would be fine and would satisfy one is red and one is yellow. But this one, it's saying the first is red and the second is yellow. So there's only half of the ways that there are to do that. Okay, so that's what the difference is. So you're looking at whether the order is important, that's a permutation or multiplication principle, or if the order is not important, you're just looking at what you have in your hand, then it's a combination. What is the probability that the first is red? Now this doesn't mention the second one, so who cares what happens to the second one? The probability that the first is red, there's 5 red out of 12, and that would be it. You wouldn't even worry about the second one because it's only asking if you reach in once. Okay, doesn't matter what happens second. Anything can happen. So we're just talking about the first one. What is the probability that the second is yellow given that the first is red? Okay, so we know that the first is red. And now we want the probability that the second is yellow. Okay, so how would we go about doing this? So we already know that a red is gone. Okay, so if we know that a red is gone, let's get our little tree here. There was 12 originally. 5 were red, 3 were yellow, and 4 were white. So we know that a red is gone. So now instead of this, we're looking at 4 are red, 3 are yellow, and 4 are white, because one of them, and then there's only 11 now. And that's what it is. So we're saying given this scenario, this has happened, what is the probability now that we get a yellow? So the probability that we now get a yellow in this new scenario is there's 3 yellow out of 11, and that would be it. Conditional probability is not too difficult if you can write what you now know. So let's try this one. The second is yellow given that the first was not yellow. So we know that there's 11 left, and we know that there's 3 yellow left, and then the rest are not yellow. And we knew that the first was not yellow. So one of these others, there was 9 of them altogether. So now there's 8. Because we know that a yellow was not removed, it was one of these other ones. So now this is our new scenario. What's the probability that it's yellow? 3 out of 11. Same answer as before. Didn't matter that the first was red, it mattered that the one taken out was not yellow. What if we were given, we wanted the probability that the second is yellow given that the first was yellow? So the red and the white are all still in there, that's 9. But we took a yellow out, so now there's only 2 yellow instead of 3. So we want the probability that it's yellow, and that would be now 2 out of 11. Okay, so these questions in this video will help with the final exam.